everybody. Today's lesson is 4-5, Simplifying Algebraic Fractions. You may have noticed by the title screen that, yes, I indeed spelled fractions wrong. Not an English guy, sorry. Funny thing, though, is when I typed up the title bar on the top, I spelled fractions wrong again, but caught it. And then when I looked at the introduction, I thought, ooh, a mistake. Anyway, less than perfect. It happens. Algebraic fractions. We're going to start simplifying those today. And fractions are one of those things that make some people go, oh, fractions. I don't like fractions. Well, fractions, people don't like them, I think, because they find them difficult. But I think if we can get a good foundation and start looking at these things properly as part of a whole, and different ways of describing parts of a whole can be the same or can be equivalent, the sooner we can wrap our mind around that and get a good foundation, I think the easier time we're going to have. Okay, so let's go ahead and delve right in. So we know that we can use fractions to compare a part of something to a whole. So what we'll talk about now, first we'll start out with what 15 minutes is as part of 1 hour. Okay, well there's 15 minutes, so what I can do is I can say 15 minutes is that much. Well, that's 15 minutes out of 60 total minutes. Or on the clock, I can say it is 1, 2, 3 twelfths. Or I can say it is 1/4 of a whole hour. So hopefully you can see that all of these three things are equivalent. Equivalent means they represent the same quantity. So they all represent the same portion of the whole. 15/60ths represents this much, so does 3/12ths, so does 1/4. We'll call this simplest terms, because this fraction, though they all mean the same things, this fraction is what we're going to call reduced. Okay, there are no common factors in the numerator, which you remember is the top of a fraction, and the denominator. In these, there are common factors. Factors, things that are multiplied. Common means they're the same. They have them in common. Okay, so we're going to tie together some of the things that we talked about previously. Factoring, prime factoring, and common factors, and greatest common factors. Okay, so let's go see how we're going to put all this together. We'll start with the definition of simplest form. We'll say it this way. A fraction is said to be in simplest form when the GCF, the greatest common factor of the numerator and the denominator, is 1, which means that the numerator and the denominator have no more factors, remember things that are being multiplied, no more factors in common. So we'll say simplest form would be examples. One we just saw was 1/4 is in simplest form because there's no factor in common of 1 with 1 and 4 other than 1. Okay, yes, 1 divides evenly into 1 and 4, but that's the only thing. So non-simplest form, well, we talked about 1 being 15/60ths because 15 and 60 have more factors in common than just 1. 3, for example, or 5, for example, or 15, for example. Okay, so these fractions are equivalent. They represent the same quantity. 1/4 and 15/60ths represent the same portion of a whole, but one fraction is in simplest form. The other is in not simplest form or non-simplest form. So we want to always reduce our fractions to simplest form. And the way we do that really isn't overly complicated. Let's have a look. If we were asked, for example, to write 9/12ths in simplest form, okay, we can see that, hopefully you can see, that this is not in simplest form because there are factors that divide evenly into 9 and into 12 that are not 1. Right? I can find something that divides evenly into 9, and that thing also divides evenly into 12. So this is not in simplest form. So here's the process by which we will go about writing it in simplest form, and the reason it ends up being in simplest form. So what I'm going to do is I'm going to start with 9/12, and I'm going to write the numerator and the denominator as a product of its factors. Okay, or I'm going to do the prime factorization of the numerator and the denominator. I'm not going to change anything, but I'm going to say 9 is 3 times 3. And 12 is 3 times 4, and 4 is 2 times 2, so I'm going to write it as 2 times 2, that's 4 times 3, which is 12. Now what I've got here is there are common factors of 3, right? You can see that pretty well. Well, what happens in a fraction if I have something over itself? Do you know what that equals? Of course you do. That equals 1. So when I have this factor of 3 above this factor of 3, this equals a factor of 1. A factor, something that is multiplied. What happens when you multiply anything times 1? Right, remember 1 is the identity element under multiplication. Maybe you remember that from earlier lessons. But the identity element 1 means that when I multiply this by anything, it remains unchanged. So when I have this 1 here, I've got 1 times what I have left over. And what I have left over is a numerator of 3 and a denominator of 2 times 2. Well, I'm going to go back now and multiply them back together and get 3/4. So these two fractions are equivalent, but this fraction here is written in simplest forms because anything over itself equals 1. So what I'm doing is I'm arranging these factors so that I can align things something over itself, and that is a factor of 1, and then when I multiply it, it remains unchanged. Let's try another example. So we are asked to write 15/60 in simplest form. Got it yet? We already talked about it, so you know the answer. Well, we could look back in the video if you want to know the answer, but it's not about the answer, remember. This class is not about the answer, it's about learning the process so that when the material gets challenging, you have something to fall back on. These are pretty easy, but we're learning the process, not trying to get the answer to this question. So I'll start out with 15/60, and I'm going to write that. What does that equal? Well, I'm going to find the prime factorization of 15. That's not so bad. 3 times 5 divided by the prime factorization of 60. And what's 60 equal to? Well, 60 is equal to 6 times 10. 6 is 2 times 3. And 10 is 2 times 2 times 5. Remember, it's all multiplication because it's prime factorization. So factors are things that are multiplied. And now what I can do is and I sort of foreshadow because I know how it's going to turn out, line up these factors. So there's a factor of 3/3, and anything over itself equals, right, 1, a factor of 1. Here is 5/5, anything over itself equals, right, 1. So what I've got is 1 times what's left over. What's left over, I've got a factor of 1 on the top. So don't think, hey, these go away, they cancel, I'll scratch them out. Okay, and you may have heard of this as canceling. I don't like canceling because things aren't really going away. We're just aligning factors so that I have something over itself which equals 1. So on the top, I've got a factor of 1. That's something that's being multiplied. So I have a factor of 1 left on the top. And on the bottom, I've got a factor of 2 times 1 times 2 times 1 is 4, and we end up with the same 1/4 or 1/4 that we did at the beginning of the video. Here's a good question. 88 feet is what part of 1 mile? Okay, well, where do we start? Well, 88 feet is part of the whole, so 88 feet is what part of the whole? Well, how many feet are in 1 whole mile? Do you know this? Do you know this? Might have to use the Google box. How about 5,280? Turns out this is 1 whole mile, so 88 feet is how many parts of 1 whole mile? Okay, now this fraction, I'll need to find out if it is in simplest terms, and I'm going to do that by factoring. So 88, I need to find the prime factorization. 88 is 8 times 11. That one's not so bad, not so hard to figure out. So 11 is already prime. Is 8 prime? Now 8 is not prime because 8 is even, so it's divisible by 2. And maybe by now you've factored enough that you know 8 is 2 times 2 times 2. What about 5,280? Oh my goodness, we may have to do that off to the side. 5,280. Okay, 5,280. I did the work on the side. I'm going to let you do it on the side too. On your own. So there is 2 times 2 times 2 times 2 times 2 times 3 times 5 times 11. 5,280 is a big number. 2, 4, 5 2s, and then 3 times 5 times 11. So now what I can do is I can cancel common factors or align factors of 1s. So there's 2 over 2. So there's a factor of 1. There's 2 over 2. There's a factor of 1. There's 2 over 2. There's a factor of 1. There's 11 over 11. There's a factor of 1. So what I'm left with is a factor of 1 in the numerator. And on the bottom, I'm left with 2 times 2 times 3 times 5. 4 times 3 is 6. No, not even close. Sorry. 4 times 3 is 12. Times 5 is 6t. That's what I was after. So it turns out that 88 feet is 1/60th of a mile. Okay, what happens if it gets just a little more challenging? Well, what I'm hoping is, if you're learning the process properly, there's no such thing as more challenging. Because if you know how to do all the previous ones, then you know how to do this question. So let's see if we do. 21 x squared y over 35 xy. The process by which I do these are exactly the same. So I'm going to factor the numerator. 21 is 3 times 7, and both of those are prime, so 3 times 7. X squared means x times x, and y means, well, times y. 35, what's 35? 35 is 5 times 7, both of those are prime, times 1 factor of x, times 1 factor of y. I'll foreshadow here and line them up, because now I can find all of my common factors on the top and the bottom, because anything over itself equals 1. So there's a factor of 1, there's a factor of 1, and there's a factor of 1. So what I'm left with is, on the top, factors 3 and x, so I'll multiply those back together, 3x, and on the bottom I'm left with 5 times just factors of 1 is 5, so I end up with 21x squared y over 35xy in simplest form, or reduces down to is another way to say it, 3x over 5. Okay, so again, this is why I emphasize so strongly process, because if you know how to do the other ones, these really aren't much more difficult. It's all about knowing how to do it, fellas. Okay, that's it for now. See you next time.
If I